Thank you for watching Knowledge Academy. Since it's a really big topic and we have a limited time, so what are you going to do? We're going to talk about something surfaces in space. Okay, surfaces means 3D. First of all, surfaces mean 3D. Now here, I have a bunch of options. I can make like this, I can make like this, and I can make like anything, right? Now I have an infinite number of possibilities. I have infinite possibilities. I can draw surfaces in space, but I'm going to limit myself. I'm going to limit myself to limited, limited shapes. And basically my limited shape is my standard shape, like hyperbola, parabola, you know, sphere. Um, Other than that, there is a standard equation for standard shape. Okay, I'm just going step by step. Limited shapes we're gonna consider for this topic, and I'm gonna go to standard shapes. They're gonna go standard shape always came from standard equation, and this standard equation name is quadric surfaces or quadratic equation, not quadratic, but quadratic came from the same one. It's called quadric surfaces. Okay. Now this quadric surfaces or quadric equation is pretty big. Let's write this one. A x squared plus b y squared plus cz squared. Okay. Cz squared plus d, another constant xy, plus y xz, sorry, xz. Let's go other way a little bit. And then f yz plus g x plus h y plus I z plus j equal to 0. So really, this is only constant here. It's really only constant here. Okay. It's pretty big equation to remember, right? It's pretty big equation. We don't want to remember that equation, by the way. But the good part is that all you can do, you can pick and choose. You can pick and choose. Let's suppose you want to pick this guy, this guy, this guy. So let's suppose you can only pick these three and leave everything rest of it zero. So, and then if you do like that, it's going to be making equation like a sphere. Sphere mean 3D, so it's going to be like this. Then you decided, you know what, I'm not comfortable with that. Let's do one, just try to test something. You include this factor, then you include this factor, and this is your x, this is your y. So you're going to add dz. So maybe what's going to happen, if you start scratching your you know, stretching your surface, maybe like this, maybe this way. If you want to stretch on the other way, like on the up, it's going to be stretching maybe this way. If you go to this factor, this one, maybe this one, right? So if you want to pick this one, xz, and this is your x, is going to be stretching this way, but it's going to keep it here. So bottom line is that you can make this shape, you can make this shape, you can make that shape, you can make that shape. In fact, if you stretch too much, it's going to be stretch. It's going to be stretched like this, and you're going to be breaking from here. So it's going to be making two surfaces. Okay. And this is a whole game of making different shapes. So in order to cover those, I'm going to be just go over the standard form of shapes. So let's do the standard form of shapes. In that equation, are you guys able to see image called quadric surfaces have two shapes are given?
Yes.
Yes.
Yeah. So if you go back again, take a look into this equation. All I did, I take these three, ignore all of them, and keep this C. So really it's going to be ax squared plus by squared plus c squared or something, maybe whatever, 12. Let's suppose 12. Right? And from here, I'm going to be taking this 12 and divided by everything. 12 divided by 12, divided by 12, divided by 12. Okay. And this is exactly what I'm doing here. So I'm going to go to the next slide. Okay, so look at that way we work. We were talking about, we have pretty much a standard equation, and what we did, we just take ax squared plus by squared plus z squared equal to whatever constant. I'm going to use 1 here, and then this is exactly written. And if I use the symbol 12, and what I'm going to do, I'm going to take the 12 from here and divide it by this, divided by that, divided by that. So my goal is that to leave 1 here, and rest of him is telling me whatever is the constant in that. Okay. And this is the shape, we call it ellipsoid. This is a shape you can call ellipsoid. Same thing if you have equations given, but one of them is minus, like z is minus. So I suppose ax squared plus by squared minus c squared equal to 1. It means c or z have a minus symbol. It means whatever comes in the minus is open. It's open. So really z is here, is open. This one is closed, this one is closed, and the minus z is open. So you can see in this shape, hyperboloid, this z is coming because this is a minus sign. If you want to trace them, you can trace them. Eventually, you're going to become up to the same shape. I'll show you a tool how you can quickly trace them without drawing all these coordinates. And what is the tracing means? When I say trace means these red lines, these lines, the backside lines. Okay, now in this equation, if you substitute z equals to 0, what's going to happen? If you substitute z equals to 0, only x and y left, and it's going to look like this: x squared plus y squared equal to 0, pretty much. Because if this guy is 0, you're going to take everything on the other side. If something there is something there, is not there, is not there, you can maybe leave 1. If you want to leave 1, you can leave it 1. But the thing is that if this whole term is gone, what's going to happen? This is basically a circle left. So x squared plus y squared equal to 1, or maybe 12 or 14, whatever. This is basically a circle equation. And you can see here, there is a circle. So this red color circle, what I'm passing my pointer right now, the value of z equals to 0. Okay. Same thing if somebody asking you draw this line, what you're going to do? You're going to take a, you know what? At this line, y equals to 0. Y equals to 0. And at this point, y equals to 0 and z equals to 0 as well, right? Z equals to 0 and y equals, both are 0 at this point. So that's what you do. You get this point, you get this point, you get this point, this point, this point, and then attach them. Same thing here. If you have two axes are in the negative, all you can do is just make sure that the two axes are not attached, right? Only here look like the z-axis is a positive sign. So z-axis positive sign means look like these two heads or these caps are here and there, but they are not attaching in this is a y direction, so they are not, there's nothing here. And same thing in x direction, there is nothing here really attached, right? Only from the z only you can see closed shape. From x and y axis you cannot see the closed shape. So that is how you're going to be drawing. If I change this guy, think about it. If I'm going to change this guy, it's going to look like z. It's not going to look like, I'm going to say it like this: y squared over b squared minus z squared over c squared minus x squared over a squared equals to 1. In that case, what's going to happen? Only if I switch back and forth, we move this guy over here, move this guy over here, what's going to happen? Only y has positive, so it means my shape is going to look like this. But from the top is open, from this side is open, but if you go to the y side, it's going to be closed. You can see there is a circle because only y is here in that case. And same thing, this called elliptic cone. Elliptic cone is same thing. The only thing is that they have two positive. You can see here. Two positive means you should see two closed shape. So one is closed, right? Another one from here is closed, right? You can see, but it's not gonna be. It's gonna be pretty much touching. As soon as you make this guy negative, this touch is gone. Detach. Okay. All you have to do in this topic is just remember these 6 shape. How does it look like? That's all you have to do. Not much. Here, elliptical paraboloid. In elliptical paraboloid, two have two squares. One is linear. The one is linear where it is open. The one is linear where it's open. The other two you can see a curve here, a curve here. Why we see the curve here? Because you have squares. But this one is linear. You can only basically see a plane. Really on the top, as you can see a plane, like 2D plane, right? Other than that, this one is hyperboloid, paraboloid. So it's gonna be combine the two, right? It's really is combining the two, stretching. And the only difference between elliptical paraboloid or hyperbolic paraboloid is you have negative sign in the center. So what we can do, since we have a limited time, we're going to be using this shape, and I'm going to be writing a bunch of shapes here. And you guys tell me what is what. A, I'm going to say it's A here. Look into the A and then go back and we're going to see something and then talk about that. And A. What you guys think the A is going to be look like? Hyperbolic, paraboloid. That's true. And if I want to write the equation for this, is going to be look like pretty much go back here, right? And it's going to be A. So maybe I can write equation for A. It's going to be look like this: 4x squared minus 5 squared plus 4z equal to 0. If you rearrange this thing, right? If you want to rearrange this thing, you can, and you're going to go to this shape. All you have to do is just leave the z from here and then bring everything back on the other side. So you're going to say, oh, you know what? Minus 4z equals to 4x squared minus y squared, and then take minus 4 divided by, so it's going to be minus, right? This is minus, so it's going to be y squared over 4 minus x squared divided by 1 equal to 0. Can we look into that again? Go back and look at the paraboloid shape. Yeah, right, that's the equation. This is pretty much what we have, right? We have a different number here, which based on how much am I going this way or I'm going a little bit flatter. Depends on how my constant are. Okay, let's do the B part. B. B will be what? Elliptic cone. B will be elliptic cone right here. This guy, right? Elliptic cone right here. C. ellipsoid, this is easy one. So D, look at the D, elliptic paraboloid, right? Elliptic paraboloid is right there. The only difference here is ours are not given. Ours are not given in the same axes. Maybe you can see here Z. So maybe if my have X, I should be drawing like this, right? And this is my X axis. If I have you don't have a Z here, if I have an X, I'm going to change my shape. So let's do this. Yeah, D will be, where is my D? Elliptic paraboloid. E, two shade hyperboloid. And which one is that? You can see here is two sheet because two separate sheet. Like this one sheet and two sheets. So really, if I can see here, heck is that? Yeah, this is a hyperboloid for one sheet, hyperboloid for one sheet. So it's basically you're taking a piece of paper and then you make like a wrap, and this is only one sheet. It's connected everywhere. But if I try to keep stretching them, stretching is going to be detached from here, and there's going to be two sheets. You can see here really having two minuses and one positive. One positive is the one I told you, Z. You can see this. So if you flip flop them, you maybe ended up on making this, or you're going to be ended up making one is here and the other one is on the other side. You know, we're connected like this based on your configuration. Okay. So E, we got a two sheet hyperboloid. Okay. These names are kind of very hard to pass from our tongue. They are complicated names. Do the last one so we can wrap up this one. F is basically one sheet, right? Hyperboloid. Thank you for watching Knowledge Academy.